In this video, we're going to learn about sketching the graph y equals a times the cosine of x and y equals a times the sine of x. So what does that mean? I'm going to be sketching these graphs, sine and cosine, with an amplitude other than 1. But before we talk about amplitude and how it changes, I just wanted to go over our basic parent functions of sine and cosine, talk about the graphs a little bit so that you get a better understanding of what amplitude is and how it changes a graph. So on the right side of the screen here, you'll see I have graphed the function y is equal to the sine of x. So you can see I have it typed in, and if you're curious, I'm using this Desmos app, Desmos, D-E-S-M-O-S. It's a free app that you can get from the App Store, either from the App Store or from the Google Play Store if you have an Android phone. And you can just go to www.desmos.com and use this graphing calculator also on any web browser. So I graphed for you the sine of x, so I just wanted to explain something about this function. It's what's called a periodic function because it repeats, it has a cycle. And we call the cycle in math, we call it a period. So I broke down for you on the left-hand side what a period of the graph looks like so we can kind of analyze and see what's happening with our sine function. Okay. So I have this graph for you, and we notice that the graph you saw just kind of goes up and down, up and down, up and down. So what we're going to do is we're going to look at one period of the function, which means one place where it starts and then it goes through a whole entire cycle, and then once it gets to this cycle, it's just going to repeat. So this one would go up and this one would go down, and it would kind of look something, well, that's really sloppy. It would kind of look something like that, okay? And it would just keep repeating. But we're just going to stick with looking at one period so that you can get a better idea of how this works. So the first thing that you'll want to know is where the points come from. So down here, I'm going to just shrink this down a little bit so you can see it. So I get my points, I used my unit circle so that you can kind of see also why the graph is periodic, why it just keeps repeating the same thing. So on my unit circle, I chose my points that are going to be like my axes points. So if I zoom this in right here, so we're talking at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And remember, when we read on our unit circle, we have a cosine value in our x position of our coordinate and a sine value in the y position for our coordinate. So if I'm looking at the sine of 0, okay, so here is 0, the sine is going to be my y value. In that case, it's going to be 0. If I look at pi over 2, which is at the top of my y-axis, my sine value is 1. Then I go to pi, my sine value is 0. Just so you see, I'm right here, my sine value is 0. If I go to 3 pi over 2, my sine value is -1. And if I go all the way back to the very beginning, 0 or 2 pi, all the way around my circle, I'm back to a point of 0. So what I did is I took these ordered pairs, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0, and I graphed them on my graph. I spread out when I did, like when I made my axes, I spread it out so that it was, 3, I guess we'll call it units for lack of a better term, but like 3 spaces on my graph, just so you could kind of see the pattern, and I could just write some stuff in here so it's bigger. You can space them out however you want. You could make them one every, tick mark on your graph. It just makes the graph kind of small and sometimes hard to write all the information. So that's going to be one period, and I know it's going to be one period because if I started continuing to count, you have to remember I went all the way around my circle, so now if I just go all the way around my circle again, I'm going to end up with the same values, which is why we call this a periodic function, because our values are just repeating. Okay, so I plotted my 5 points and I drew out one period of my graph. So here's a period of my graph like this. Okay, now I'm going to draw it in here that all the way to 2 pi, this is going to be my period. Okay, The other thing that you'll want to notice is this, what's called the amplitude. The amplitude is from my axis all the way, all the way up to my peak, and from my axis all the way down to my valley. Okay, this is what's called the amplitude. Okay, and you can call it the height of your bump. Okay, so that's what the basic sine function looks like. So the easiest thing to remember is that the sine function starts at 0. It starts at the origin, and it goes up, down, up. Okay, that's how I remember it. Okay, so let's look at the cosine graph. Now the cosine graph, if we come over here, I'll let you see the Desmos one. If I come over here, and now instead of sine, I'm going to graph cosine. Okay, you'll notice that the graph looks similar. It's just a little bit, here I'll show you, if I look down here, it's a little bit shifted. Notice that it doesn't start at the origin, okay? But you'll see that it's periodic, that it just keeps on repeating. So for the purposes of this lesson, we're just going to examine one period. All right, so if I look at the cosine graph, I drew out one period for you, but I'd like to show you where my points come from again. Again, I chose my unit circle to help me figure this out. So if I look at 0, so right here, at 0, my value is 1. Remember, it's my x value, so I'm looking at these values here. Okay, when I go to pi over 2, my x value is 0. When I go to pi, my x value is -1 here. When I go to 3 pi over 2, my x value is equal to 0. And when I go to 2 pi, my x value is 1. So you can see that my values are going to start to repeat. Okay, so here's what my graph looks like of cosine. So the cosine graph, you remember kind of, instead of going up, down, up like the sine one goes, it goes down and then up. That's how I remember it. So the cosine one is the graph that starts up, and the sine one is the graph that starts at the origin or starts down. Okay, same concept though. My period, it repeats every 2 pi. So this is going to be my period. And we also have an amplitude. The amplitude is again from my axis to my peak, and my axis to my valley or my bumps. So this is my amplitude. Also, this is my amplitude, and it's the same. So my amplitude is 1, just like cosine. It's going all the way up to 1 and then back down, and then all, down to -1, and then up through 0, and then all the way up to 1. So the height of my bump is always going to equal 1. So now, if I put a number out in front that we call A, and I remember they do use A written as the actual formula, but A, I remember, stands for amplitude. It represents the amplitude, and it changes the height of the bump. So let's just see what's going to happen. So I have a graph kind of sketched out for you, at least my coordinate plane, but I want to go through the ordered pairs and show you what happens. So I've come down here, and let's pick our ordered pairs. So kind of zoom this in a little bit. So y is equal to 2 times the sine of x. So this is the same as 2 times the sine of 0. Okay, I know that the sine of 0 is 0, so this is 2 times 0, which is 0. Okay, then pi over 2, so this is same as 2 times the sine of pi over 2. The sine of pi over 2 is, here, is 2 times 1, which is equal to 2. Now I do the same thing. What's 2 times the sine of pi? Well, the sine of pi is 0, so 2 times 0 is equal to 0. Then 3 pi over 2, I'm right here, so 2 times the sine of 3 pi over 2, or 2 times -1 gives me -2, and 2 times the sine of 2 pi, sine of 2 pi is 0, or 0. So I'm graphing the ordered pairs 0, 0, pi over 2, 2, pi 0, 3 pi over 2, negative 2, and 2 pi 0. So I'm going to go ahead and I'm going to graph these. So I'm at 0, 0. My next point is pi over 2, 2. Then I'm at pi 0. Then I'm at 3 pi over 2, negative 2, and 2 pi 0. So if I go ahead and I sketch my graph, what happened to it? Well, my period stayed the same because it's still repeating once every 2 pi, because when I know that because once I got to 2 pi down here, I started getting the same answers, 0, 2, 0, negative 2, 0. If I kept on with that same pattern, again, I'm just making my way around the circle. I went around my circle once, I go around the circle again, I'm going to get the same answers. But now my amplitude has changed. The height of my bump is different. So this number out in front, the A value, is going to tell you what's the height of your bump. So do you have to go through every time and do this? No. You can use your basic 5 points of your parent function. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0, and adjust the amplitude based on the number in front. And the same thing works for cosine. So let's try a cosine graph without doing the ordered pairs and see what we get. Okay, so I just wrote this for you. The rule is the same for a times the cosine of x. We just use our set of ordered pairs for the parent function cosine. So remember, the cosine is the graph that starts up, down, up. So remember, cosine looks like up, down, up. Well, that's a really bad graph, but up, down, up like that. Okay, so now I want to try graphing y equals 1/2 times the cosine of x. So it might help you to just start graphing. If I wanted to look at my parent function, I would say, okay, it's at, these are my points. Okay, it starts up, down, up. But I have an amplitude change. My amplitude change is 1/2, which means the height of my bump is only going to be 1/2. So my points now are going to be here. So what is my graph going to look like? Up, down, up. Because now my amplitude is here to here, or here to here, and only 1/2. If I gave you a different number, let's just say I said, I don't know if I'm going to have the space for this, but what if I said it was 3? Then I would go up to 3 and down 3 to 3. Okay, so if I extended my axes, it would look like this. And I made my points. I'm going to make this 3 orange just so that you can see the graph. So if I made my points, I would start at 3. 3, 0, negative 3, 0, 3. So now my graph would look like this. Changes the amplitude. So hopefully that helps you understand the amplitude of sine and cosine, and then just the basics of just the periodic functions sine and cosine. If you have any questions, let me know. Good luck.